Hello everyone, welcome to the Unacademy. Dear friends, sorry for the inconvenience. Actually ये class जो है 6 p.m. schedule था, but due to some internet issues, I was not able to attend that particular class or session. So let's start. Let's crack the GATE ESE with India's largest online learning platform. Get the plus subscription now and start unlimited live and the recorded video lectures by India's top educator. My dear friends, there is a great announcement for all of you. Unacademy is organizing a combat, okay, on 16th December at 6 p.m. So let me tell you about the combat. This is the India's largest for 90 competition for the gate. ठीक है ना, यहाँ पर जो चैलेंजिंग क्वेश्चंस है that will be created by the India's best educators, super fast and the fun with the real time ranking. उसी समय आपके रैंकिंग भी डिसाइड होंगे, compete with the best. ठीक है ना, बहुत सारे जितने भी ऑल ओवर इंडिया लेवल पे स्टूडेंट्स हैं जो सेल्फ प्रिपरेशन किए हैं या कहीं से भी किए हैं, all of them can just join this combat on the 16th December at 6 p.m. and these are the exciting prize. So अगर आप इस टेस्ट में टॉप करते हैं तो दोस्तों आपको मिलने वाला है मैकबुक. ठीक है ना. So this is just for the fun and just for testing yourself. What is your ranking, what is your position and where you need some improvement. देखिए लाइफ में एक ऐसा मोड़ आता है जहां पर अपने आप को इवैल्यूएट करना, अपने आप को लाखों बच्चों के सामने रख कर करके जज करना बहुत ही जरूरी होता है. सो डियर फ्रेंड्स, डोंट बी लेट, बी रेडी ऑन द 16 दिसंबर एट 6 p.m. टू अटेंड दिस अनअकैडमी कॉम्बैट. ओके, सो आपके टेस्ट अपियर होने के बाद अ डिटेल्ड सॉल्यूशन will be given by the top educators. So this is the wonderful thing that we are going to have on a 16th December with the exciting prize. The first one is the MacBook, second winner will get the Apple iPad and the third winner will get the Apple AirPods. Okay, and the rest of top 100 rankers will get the voucher of 1000 of like Amazon. You can get the purchasing of anything from the Amazon with that particular test. So myself, Ajay Das, I'm taking computer science. I have a 8+ year of teaching experience. Till now I have mentored almost 20,000 engineering students for the GATE. Work as a freelancer in many reputed institutes of India. Also qualified the GATE exam 5 times. Qualified the Chhattisgarh State Electricity Board exam with the AIR 8 in 2010. So download the Unacademy learning app and start your journey with India's top educators sitting anywhere, anytime. कहीं पर भी आप बैठ करके अपने प्रिपरेशन को एक अच्छा डायरेक्शन दे सकते हैं, एक अच्छा थॉट दे सकते हैं. Are you getting my point or not? So what you will get, this is the major question that always used to arise in everyone's minds, and I have only written here the some formal things that you are going to have once you will take the subscription from the Unacademy. First one is the daily live session, second one is the structure courses and PDF, third one is the live test and quizzes and unlimited access. You can access the lecture again and again until you get the entire concept. So these are the very basic thing. You might be thinking that sir ki this part already I am getting from the other online platform. So what is the different inside you? My dear friends, learn with the top educator, because जितने भी इंडिया में रैंकर्स होते हैं उसका 90% क्रेडिट जाता है फैकल्टीज को. So if you will have a guideline, if you will have a like teaching from India's best educator, means no compromise in quality. अगर क्वालिटी में कोई कॉम्प्रोमाइज नहीं होगा तो आपके रिजल्ट्स में भी कोई कॉम्प्रोमाइज नहीं होने वाला है. So I have only listed the few of the educators associated with the Unacademy from the like electrical, electronics, civil, similarly from the mechanical. But if you want to know more about the educators, what you can do, you can download the Unacademy learning app and you can check the profile of each and every educators, those who are associated with the Unacademy. उनका प्रोफाइल को चेक करिए, उनके फ्री स्पेशल क्लासेस को अटेंड करिए, एंड आफ्टर अटेंडिंग द फ्री स्पेशल क्लासेस एंड आफ्टर हैविंग अ पॉजिटिव थॉट्स, देन गो फॉर द सब्सक्रिप्शन. माय डियर फ्रेंड्स, किसी भी फ्री स्पेशल क्लासेस को अटेंड करने के लिए दे आर आस्किंग फॉर अ कोड. यू कैन यूज दिस कोड टू अटेंड द free special class. Are you getting my point? AIEFA, IFA, and the same code will be applicable to get the discount on the सब्सक्रिप्शन. दोनों पर्पस के लिए वैलिड है. अगर आप स्पेशल क्लासेस को अटेंड करना चाहते हैं तो वो एक अनलॉक कोड मांगेगा, वहां पर आप इसको यूज कर सकते हो. एंड द नेक्स्ट वन इज द फॉर द सब्सक्रिप्शंस. सो यू नो गेट ईएससी में बहुत सारे ब्रांचेस के लिए गेट ईएससी एग्जाम कंडक्ट कराए जाते हैं, बट फॉर विच ब्रांचेस अनअकैडमी इज गिविंग योर ट्रेनिंग फॉर द गेट एंड ईएससी आई हैव लिस्टेड डाउन ओवर हियर. So you can check like mechanical, computer science, instrumentation, production, electrical, electronics, civil, chemical. So these are the branches for which the Unacademy is giving you a training for the GATE and ESE. So according to your branch, my dear friends, you can choose the subscription and you can move ahead. So as you know, there are two different kind of subscription model. So already the plus subscription model is executing from the last 2 years. This was the first subscription model the Unacademy has launched like in last 2 years, and it is already running till now. And there are another subscription model which is the Iconic, which recently launched by the Unacademy. So in this slide I have mentioned the fee structure of the plus subscription. So you can see over here for the 1 month it is a 5,500, for the 3 months it is a 13,000, for the 6 month it is a 24,000 around, and similarly for the 12 month it is a 40,000. So my dear friends, if you are in a final year or the pass out, I will suggest go for the 12 month of subscription. In that situation your fee structure will be this, and once you will apply the code IFA which is written over here, once you will apply the code IFA, you will get minimum 10% discount. How much? Minimum 10% discount, and your final applicable fees will become this. After the discount, this is your applicable fees. Similarly, if you are in a second year or the third year, then might be you are looking for the GATE 2022 or the 23, because already you know the third year student can also appear for the GATE exam. So in that situation you can either go for the 18 month or 24 month of subscription, and your fee structure for the 18 month is around 38,000 and the 24 month is 44,000. But once again you will apply the code IFA, you will get the minimum 10% discount, and these are the discounted fees. Now let's talk about the Iconic. So inside the Iconic you are not going to have a 1, 3 or 6 month of subscription. If you want to go for the Iconic, then either you can go for the 12 month or you can go for the 24 month. The fee structure of the 12 month is around 50,000 and 24 month is around 74,000. So might be you are thinking, sir, there is a difference of 40% in fees between the plus and Iconic. Why? So my dear friends, of course अगर कोई भी सब्सक्रिप्शन मॉडल का फीस थोड़ा सा भी हाई होता है या थोड़ा अधिक हाई होता है तो उसके पीछे कुछ ना कुछ रीजन होता है. The additional things must be you are going to have in case of Iconic. Got it, all of you? So पहले तो मैं आपको Iconic के बारे में बता दूं. Iconic सब्सक्रिप्शन बेसिकली वैसे स्टूडेंट्स के लिए डिजाइन किया गया है जो कॉन्सेप्चुअली थोड़ा सा वीक है, जो बहुत ज्यादा हिम्मत नहीं बना पाते हैं कि भाई गेट का तैयारी करें या ना करें, जो अभी भी डायलेमा में है. उन सारे बच्चों के लिए जिनके अंदर कॉन्फिडेंस नहीं आ पा रहा है, उन सारे स्टूडेंट्स के लिए Iconic kind of subscription was designed. And what is the best part of the Iconic? That you can choose your personal coach, or you can say personal trainer, or you can say personal mentor or guide, anything you can say. So वो गाइड आपको टाइम टू टाइम असिस्ट करता रहेगा आपके डाउट सॉल्विंग में. आपके आपने बहुत जगह देखा होगा ऑफलाइन क्लासेस चलती है, टीचर आते हैं पढ़ाते हैं चले जाते हैं, लेकिन बाद में अगर कोई क्वेरी पूछना है तो क्लास के समय ही आप पूछ सकते हो. उसके बाद अगर कोई भी डाउट्स होते हैं, क्वेरी हो सकते हैं, आप व्हाट्सअप करते हैं, 10 दिन के बाद रिप्लाई आया तो आया, नहीं तो वो भी नहीं आता है. सो दिस काइंड ऑफ हर्डल्स वी हैव कंप्लीटली रिमूव. और जो वीकर सेक्शन के स्टूडेंट्स होते हैं, जिनका कॉन्सेप्ट उतना नहीं बन पा रहा है, जिनके अंदर कॉन्फिडेंस नहीं आ पा रहा है, वो और कॉन्फिडेंस लूज कर जाते हैं, और एंड आफ्टर द 3 month 6 month he or she drop the preparation. So we have avoided those kind of hurdles in case of Iconic subscription. तो यहां पर जिस कोच को भी आप सेलेक्ट करोगे, he will be with you till your final GATE exam. और वो आपको कॉन्सेप्ट हो, न्यूमेरिकल सॉल्विंग्स हो, कैसे प्रिपरेशन होना चाहिए उसका स्ट्रैटेजी हो, टाइम टू टाइम प्रॉपर गाइडलाइन, एवरीथिंग he or she will provide you. Are you getting my point or not? So all the time we will keep you boosted, we will keep you boosted. आप हमेशा boost रहोगे और आपको एक प्रिपरेशन को डायरेक्शन मिलता रहेगा. So let's see the difference between the plus and iconic. Already I have told you a lot of things about the iconic. So my dear friends, if you are looking for the plus subscription, these are the things which you are getting inside the plus. So first one is the India's best educator. Of course you will get it in all kind of subscription because this is our main like weapon. Are you getting my point or not? So interactive live session, structured courses and PDF, live test and quizzes. So these are the things which you are getting in the plus subscription. Now let's see what is the iconic. So all the things that you are getting in the plus definitely you will get in the iconic. But what are the additional things that you are going to have in case of iconic? So the first thing is personal coach. ठीक है ना, जो आपके साथ एक साय की तरह आपके साथ रहेगा जब तक आपका गेट या ईएसी का एग्जाम नहीं होता है. नाउ द क्वेश्चन इज whom you will select as your personal coach. देखिए जैसे कि मैं कंप्यूटर साइंस से हूं तो मैं कंप्यूटर साइंस के बारे में बता दूं. सपोज अनअकैडमी में कंप्यूटर साइंस में 20 नंबर ऑफ एडुकेटर्स है. ऑलरेडी यू नो द अनअकैडमी कीप मल्टीपल एडुकेटर्स फॉर द सेम सब्जेक्ट. तो इसके बहुत सारे एडवांटेज हैं. लाइक अगर आपको कोई भी कॉन्सेप्ट एक पर्टिकुलर एडुकेटर से समझ में नहीं आ रहा है या किसी रीजन से छूट गया तो आप दूसरे एडुकेटर्स के सब्जेक्ट में जाकर के उसी कॉन्सेप्ट को फिर से क्या कर सकते हो, सीख सकते हो. आर यू गेटिंग माय पॉइंट और नॉट? सो इफ देयर आर 20 नंबर ऑफ एडुकेटर्स इन द कंप्यूटर साइंस फॉर द गेट, देन यू कैन चूज एनीवन as your personal coach and that coach will remains with you till your final gate exam. तो जब तक आपका गेट या ईएसी का एग्जाम नहीं होता है, अदर ब्रांचेस में ईएसी के एग्जाम होते हैं, तो जब तक आपका एग्जाम नहीं होता है तब तक वो आपको असिस्ट करता रहेगा, आपको पुश करता रहेगा, ठीक है ना, आपको मोटिवेट करता रहेगा. मींस ही विल कीप यू अलाइव, ही विल कीप यू अलाइव. लाइफ में जिंदा रहना बहुत ही जरूरी है. जिंदा इन द सेंस माइंड का अलर्ट रहना बहुत ही जरूरी है जब तक आप लाइफ में कुछ अचीव नहीं करते. Got it? So this is the first thing which you are going to have in case of iconic. The second thing is the preparatory study material. देखिए लाइफ में हर एक चीज का एक अपना अपना इंपॉर्टेंस होता है. जैसे कि हम लोग बोलते हैं ना, किसी भी कॉम्पिटेटिव एग्जाम के लिए 3 चीजों की जरूरत पड़ती है: स्टडी मटेरियल, टेस्ट सीरीज एंड क्लासरूम. And of course study material and the test series are the effect of classroom, because if you don't have a concept you can neither attend for the test series nor you can solve any problem from your study material. लेकिन इसका अपना एक रोल है जो आपको एग्जाम में ऑलमोस्ट 40% क्वेश्चन को सॉल्व करने में हेल्प करता है. आर यू गेटिंग माय पॉइंट और नॉट? क्योंकि आप इतने वेरिएशंस को क्वेश्चंस को बनाते हैं कि जब आप एग्जाम देने जाते हो तो उसमें से लगभग 40% ऐसे क्वेश्चंस होते हैं जो आपने देख रखा है और वो डायरेक्टली आ रहा है, डेटा चेंज करके या कुछ कर करके वो डायरेक्टली आ रहा है. उस क्वेश्चन को आपने देख रखा है, बना रखा है, तो ये 40 मार्क्स आपका कहीं नहीं जाने वाला है. रिमेनिंग 60 मार्क्स यू हैव टू डिसाइड कि आपने किस तरह से मेहनत की है, किस तरह के एडुकेटर से की है, एवरीथिंग. आर यू गेटिंग माय पॉइंट और नॉट? सो these are the 2 most important thing in the iconic. And apart from that, personalized test analysis means your test will be evaluated personally and you will be intimated and you will be guided also where you need some improvement. And the study planner, आपको study कैसे प्लान करना है according to your performance, these things will be discussed to you time to time. So this is all about the plus and iconic. So my dear friends, before leaving the introductory session, again I will tell you, if you want to get the subscription or if you want to watch any special classes, you can use the code. Okay, so this is used for the 2 purpose: to watch free special class or to get the subscription, under the GATE ESE. And not only for the GATE ESE, if you want to take any kind of subscription, you or your some of the friends, your colleagues, your relative wants to take any kind of subscription in the Unacademy platform, all of them can use the code IFA. Got it? All of you. So that's all about the Unacademy basic introduction. So let's start the session for which you people are waiting for. So my dear friends, let's crack it. This is the slogan of the Unacademy, because we believe that if we will train you, you would be able to crack your exam in a fast. Okay, so जैसा कि मैंने आपको बताया है कि ये जो है, जो आज हम लोग डिस्कस करने वाले हैं, दिस इज द प्रोग्रामिंग एंड द डेटा स्ट्रक्चर पार्ट 9। कल मैं इस क्लास को लेना चाह रहा था, बट ड्यू टू सम रीजन, सम टेक्निकल इश्यूज, आई वाज नॉट एबल टू कंडक्ट दिस पर्टिकुलर सेशन। ठीक है ना, कुछ इश्यूज थे जिसकी वजह से 15 मिनट के सेशन चलने के बाद वो स्टॉप हो गए। सो दैट्स व्हाई आई हैव रीशेड्यूल्ड द सेम सेशन टुडे। Okay, so let's start the things. Already I have told you this is the complete course of the programming and the data structure, and already we have covered part 1 to part 8. Now we are going to deal with the part, and from now to onwards we will look upon the binary search tree and the AVL-Tree. Means we will actually discuss about the entire binary tree. So let's see. सबसे पहले हम लोग कॉन्सेप्ट सीखेंगे, उसके बाद मैंने बहुत सारे गेट के स्टैंडर्ड न्यूमेरिकल लिए हैं, वो सब भी देखेंगे। तो चलिए हम लोग बेसिक से स्टार्ट करते हैं। स्टार्ट फ्रॉम द बेसिक, दैट इज द बाइनरी। सो माय डियर फ्रेंड्स, व्हाट इज द डेफिनेशन ऑफ बाइनरी ट्री? ऑलरेडी यू नो दैट, ठीक है ना। तो बाइनरी ट्री के डेफिनेशन को जानने से पहले ट्री के बारे में समझते हैं। ट्री का बेसिक डेफिनेशन क्या होता है? ट्री का बेसिकली डेफिनेशन क्या होता है? अ ग्राफ विदाउट साइकिल, विदाउट साइकिल, ठीक है ना। और बाइनरी का मतलब क्या होता है? बाइनरी का मतलब होता है मैक्सिमम टू वैल्यू। जैसे आप लोग पढ़ते हैं ना डिजिटल इलेक्ट्रॉनिक्स में, 0 और 1, ठीक है ना, बाइनरी डिजिट। सो बाइनरी का बेसिकली मीनिंग होता है कि मैक्सिमम टू वैल्यू, ठीक है ना। बाइनरी का मतलब होता है मैक्सिमम टू। सो कंबाइनिंग बाइनरी एंड ट्री, व्हाट विल बी द बेसिक डेफिनेशन? A tree in which a node will have maximum two child, maximum two child is called the binary tree. Let's see the example. See, and it is given as like this. Now let's see. चलिए यहां पर देखते हैं, ये अगर एक नोड है, ये अगर नोड है तो इसके कितने चाइल्ड हैं? दो चाइल्ड है, 1 and 2। इसके भी दो चाइल्ड है, इसके दो चाइल्ड है। इसके कितने चाइल्ड है? 0 है, 0 है एंड 0 है, ठीक है ना। तो ये ऑफकोर्स बाइनरी ट्री होगा, ठीक है ना। लेकिन इसके देखिए, इस केस में अगर हम लोग कंसिडर करें तो इस केस में देखिए, इसके दो चाइल्ड हैं, इसके भी दो चाइल्ड है, ठीक है ना। इसको 0 चाइल्ड है। इसके बारे में सोचें तो you might be thinking that okay, just see over here, just see over here, do one thing, just change the graph a little bit. Okay, this kind of graph is given. So here it is also a two child, this one is the 0 and this one is the 0 and this one is the 0 and 0, ठीक है ना। लेकिन यहां पर क्या है? साइकिल है। सो अगर किसी भी ग्राफ में साइकिल है तो सबसे पहले तो वो ट्री ही नहीं होगा, क्योंकि ट्री का बेसिक डेफिनेशन क्या है? अ ग्राफ विदाउट साइकिल। सो इफ देयर इज अ साइकिल देन इट विल नेवर बी अ ट्री। सो अगर ये ट्री ही नहीं है तो बाइनरी ट्री के बारे में हम लोग सोच ही नहीं सकते, ठीक है ना। नाउ लेट्स सी दिस 2 1 0। इसके दो चाइल्ड है, इसके एक चाइल्ड है, लीफ नोड है, 0 चाइल्ड है। इसके 3 चाइल्ड है, तो इसके चूंकि 3 चाइल्ड है, ऑफ कोर्स दिस इज नॉट अ बाइनरी। गॉट इट? दिस इज नॉट अ binary tree. Now let's see the basic thing of the binary tree. तो ये अगर हमारा बाइनरी ट्री है तो इन सभी को हम लोग बोलते हैं लीफ नोड। क्या बोलते हैं? लीफ नोड को आइडेंटिफाई करने का तरीका क्या है? अ नोड हैविंग अ चिल्ड्रन जीरो, ठीक है ना। जिस भी नोड का चिल्ड्रन जीरो होता है उसको हम लोग लीफ नोड बोलते हैं। एंड अपार्ट फ्रॉम दैट ऑल द नोड will be considered as all the node will be considered as internal node, means leaving the node leaf node all the node will be considered as internal, means in any binary tree there are two things, one is the leaf node and second one is the internal nodes. Now let's see the type of binary tree. Type of binary, और यही हमारा पूरा सिलेबस बनने है, binary. See, the first one is strict binary, जो हमारे गेट के सिलेबस में है उन सभी को मैं यहाँ पर मेंशन कर रहा हूँ. सेकेंड वन इज फुल बाइनरी ट्री, फुल बाइनरी. थर्ड वन इज कंप्लीट बाइनरी. फोर्थ वन इज बाइनरी सर्च. Fifth one is AVL. Sixth one is if, where we will deal the two different things, max and mean. Next one is the B-tree and plus, which is the part of AVL-Tree, is the part of AVL-Tree. So first of all we will deal the AVL-Tree and then we will see what is the B-tree and B plus. So my dear friends, these are the syllabus of your GATE exam in which you have to deal with the all these things. और अगर हम लोग यहाँ से गेट में क्वेश्चंस की बात करें तो आपको एवरी ईयर 2 to 3 क्वेश्चंस you will get from this particular portion. 2 to 3 questions you will get from this particular portion. Are you getting my point or not, all of you? Okay, Mr. M Singh. Fine. See, so these are the things which we have to study, okay, in case of binary tree. These are the variety of the binary tree. So we will start from the beginning. Strict binary tree से हम लोग start करेंगे. Then we will look upon the full, complete, then binary search tree, AVL-Tree, tree and B plus tree. So let's start from the first, that is the strict binary tree. That is the strict बाइनरी. देखिए बड़ा बेसिक सा डेफिनेशन है स्ट्रिक्ट बाइनरी ट्री का, ठीक है ना. एक ऐसा बाइनरी ट्री जिसमें किसी भी नोड का, हर एक नोड का जो डिग्री है या आप बोल सकते हैं जो चाइल्ड है, मैक्सिमम कितना हो, 0 या 2 के बीच में, 0 होगा या 2 होगा, ठीक है ना. देखिए बाइनरी ट्री, बाइनरी ट्री okay, Sai Teja, stay connected, okay, and hopefully I will try a lot of things, whenever I will deal each and everything, ठीक है ना. मैं प्रोग्रामिंग को भी साथ ही साथ ले चलूंगा. I will try to deal with all the programmings related with the binary search tree. Not a problem at all. But the most important thing is you have to be like consistent. If you really want to learn a lot of things, then you have to consistent. Okay, so just see over here. What is the basic definition of the strict binary tree, that a binary tree in which every node will have either 0 children or 2 children. A binary tree in which every node will have either 0 or 2 children. 2 children. Now let's see the example. I'm constructing a binary tree. Okay, this one is the first binary tree. This one is the second binary tree. This one is the third binary tree. So what the definition says, either a node will have a 0 or 2 children. So just look upon over here. So this node having a children 2, this node having a children 2, again this node having a children 0, 0 and 0. So definitely it will be a strict binary tree. Now look upon this particular tree. This node having a children 2, this one is also 2, but this one have 1. So this is violating the definition of the strict binary tree. Again, all the leaf node will have definitely a 0 children. So this will never be a strict binary tree. Why? Because this particular node will have a children 1. So here you can use the term children or you can use the term degree also, not a problem at all. Means what is the basic definition of the degree? Degree is nothing but number of children. Number of children. Okay, so just look upon this particular diagram. Again, this node having a degree 2, 0, 2, 0, 2, 0, 0. So definitely it will be a strict binary tree. Okay, so looking upon the tree, you can easily identify which one is the strict and which one is not. So let's see about the full binary tree. Let's talk about the full binary. Full binary. See over here. What is the basic definition of the full binary tree? See, in case of full binary tree, what will happen? Every node will have exactly 2 children except the leaf node. And all the leaf nodes should remain at the same level. Are you getting my point or not? Every node will have exactly 2 children except the leaf node, and every leaf node will stay. Yes, Sai Teja. And every leaf node will stay at the same level. So just see the definition. A binary tree in which every node has exactly 2 children except which one? Leaf 1, because leaf 1 can never be a 2 children. It will always have a 0 number of children except the leaf nodes and every leaf node should be at same level. Leaf node should be at same level. Let's see the example. My dear friends, I am using a term AND. And what is the meaning of AND? If both the conditions are true, then it will be a full binary tree. Otherwise not. Means if every node will have exactly two children as well as every leaf node belonging to the same label, then it will be known as full binary tree. So let's try to understand over here. I'm taking a different example. Just try to understand. This one is the first tree. This one is the second tree. And this one is the third tree. Okay, now let's see. So this node have a two children, this one is also have a two children, this one is also have a, sorry, this one is have a, how many children? One children. So can it be a full binary tree? Can it be a full binary tree? No. Why? Because this node do not have exactly two children. So it is not a full binary tree. Similarly, just think about this particular tree. This node having a two children, again two, again two. And these are the leaf nodes since having a children 0. And just see over here, all the leaf node are at the same label, yes or no? So how to decide the label? Of course, this is called root node call at the label 0. And this one is at the label 1. And this one is at the label 2. So in this way, you will basically decide a label, and that is nothing but the height of the tree. Got it? So every leaf node are staying at the same label, so it will become a full binary tree. Not a doubt at all. Now let's look upon this. This node having a two children, again two children, and these are the leaf node having a children 0. But in this situation, every leaf node are not in the same label, because this leaf node is staying at the label 1 and these two leaf node are staying at the label. Got it? So in this situation, this is not a full binary tree. Now let's try to derive some formula. Okay, let's try to derive some formula. See, I'm talking about full binary. Fine, let's see over here. Suppose this is the full binary tree. This is the full binary and so on. Okay, see over here. Of course, in this label, this is the label 0, and in this label, the number of nodes are, how many nodes are there? There are 2 to the power 0 number of nodes. Similarly, in this label, this is the label 1, and in this label, what is the total number of nodes? 2 nodes are there, 1 and 2. So you can write 2 to the power 1. Similarly, this is the label 2. So in this label, how many nodes are there? Please respond me. 1, 2, 3, 4. So there are 2 to the power 2 number of node. Okay, you just write it properly. There are how many? There are 2 to the power 2 number of nodes. Similarly, in this label, the total number of nodes are 2 to the power 3. And suppose this node is at the label L. This node is at the label L. So this is nothing but the height of the tree. This is nothing but the height of the tree. This is the height 1, 2, 3. Yes or no? So of course, in this label, the total number of nodes will be 2 to the power L. Will be 2 to the power L. So finally, we are trying to calculate what will be the total number of nodes in this full binary tree. So let's see over here. We are trying to calculate total number of nodes in full binary tree full binary tree up to label L, or you can say with height H, with height H. Meaning of both the statement are same. Are you getting my point or not? If you are saying up to label L, or you are saying with the height H, meaning of both the statements are same, because the number of label is nothing but the height of the tree. So this one will become 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 and plus up to dot 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 2 to the power L. So my dear friends, this one is the GP series. This one is the GP series. And what is the sum of GP series? The sum of the GP series is A into R to the power n minus 1 divided by R minus 1 if the ratio of consecutive terms is greater than 1. Or the same sum will become 1 minus R to the power n divided by 1 minus R if the ratio is less than 1. And what is the ratio over here? This is the ratio of any two consecutive terms. Consecutive का मतलब होता है just one by another. After one, that is the another terms. And what is the A over here? A is the initial term. And what is the N over here? This is nothing but number of terms. Number of terms. So my dear friends, in this series, this one is the initial term, which is nothing but A. Okay. And what are the total number of terms? You are starting from the 0 and you are going to the L. Means if you are starting from the 0 and you are going to the 9, then total number of counting are there. There are 10 number of counting. How you will identify this? This is the 9 plus 1. Yes or no? So here the value of n is nothing but L plus 1. The total number of terms is L plus 1. Now the ratio of consecutive terms. Select any two consecutive terms. Suppose we are selecting this. So this one will become 2 to the power 2 divided by 2 to the power 1 is equal to 2. This one is the ratio and this one is greater than 1, which is implying the first formula will be okay. Now let's see. So the sum will become A. What is the value of A? 2 to the power 0 into R. What is the value of R? 2 to the power n. Number of terms is L plus 1 minus 1 divided by again 2 minus 1. So this one will become 2 to the power L plus 1 minus 1, or you can write the same thing 2 to the power H plus 1 minus 1, where L is equal to H. So this one will become the total number of nodes. Total number of nodes in full binary tree. Yes or no? In full binary, just note it down. You can verify the answer. If you want, you can verify the answer whether it is correct or not. You can take any full binary tree and you can just verify the answer. Just see over here. I am considering a full binary tree. What is the height of this tree? Of course, in this situation, the height is 2. So, according to this formula, the total number of nodes will become 2 to the power 2 plus 1 minus 1. This implies 2 to the power 3 minus 1. This implies 7. Means with the height 2, with the height h is equal to 2, the total number of nodes is 7 in a full binary tree. Just count over here. 1, 2, 3, 4, 5, 6, 7. Means this formula is correct. So if you want, you can verify the answer also. Got it? So I hope this particular concept is clear to all of you. Now let's come to the another formula. Okay, these are the important formula which you have to learn. See, in a strict, or you can say full binary tree. N is equal to I into n minus 1 plus 1. So this formula is valid only for the strict n in case of full binary tree. There is a logic about each and everything. I will tell you each and everything. Please be with me. Okay, see over here. What is the L over here? This is the number of leaf nodes. This is the number of leaf node. What is the I over here? This is the number of internal nodes. Already I have discussed with you what is the meaning of leaf node and what is the meaning of internal nodes. And what is the N over here? My dear friends, N is called order of tree, or you can say number of children. Number of children, or you just add a term maximum number of children. Maximum number of children. So if I am making the value of n is equal to 2, then it will become a binary tree. It will become a binary tree. So you will say strict binary tree or the full binary tree. But if you are taking the value number of n is equal to 3, then definitely it will become ternary tree. Yes or no? So if it is a n is equal to n, you will say n-ary tree. You will say n-ary. Got it? All of you. Now let's try to verify whether the formula which I have written over here is correct or not in case of strict or the full binary tree. Just see over here. Suppose I am considering a tree. Okay, I am considering a tree. So just see over here. This is the strict binary tree. Yes or no? Because what is the definition of the strict binary tree? The node will have either 0 or 2 children. So here every node will have either 0 or 2 children. Yes or no? 0 or 2 children. So if you know the number of internal nodes, how many internal nodes are there? 1, 2 and 3. And since this is the binary tree, so the value of n is equal to 2. So the number of leaf node will be what? The number of leaf node is equal to I into n minus 1 plus 1. So this implies I. What is the value of I over here? This is the 3 and n 2 minus 1 plus 1. And this is the 3 plus 1 and this implies 4. So the number of leaf node that you are getting is 4. Of course, in case of binary tree, the number of leaf node is equal to internal node plus. In case of binary tree, the total number of leaf node will become number of internal node plus 1. And this is valid everywhere. This is valid everywhere if it is a strict or the full binary tree. So this is the first example that we have considered. Now let's test on the full binary tree. Just see over here. Just see over. Again, this is the full binary tree. So here, what is the total number of internal node? The number of internal node is I is equal to 3. And what is the total number of leaf node? The number of leaf node is 4. So definitely, if the internal node is 3, then 3 plus 1, the total number of leaf node will become 4. Got it? Everyone. So we have tested the things in a strict binary tree or the full binary tree. Now let's think about the strict ternary or the strict full ternary tree. Okay, so just see over here, example number 3. So this one is the case. Okay, now let's see on here. So this node having a degree 3, degree 3, degree 3, and remaining are the leaf nodes, so definitely the degree will become 0. So definitely looking upon the 3, you can say this is the ternary tree. And in case of ternary tree, the value of n is equal to 3. So my dear friends, how many internal nodes are there? So this one, and this one. There are 3 number of internal nodes. So the value of I will become 3. So let's try to find out the number of leaf node. So the number of leaf node will become I into n minus 1 plus 1. So internal node is 3. So 3 into 3 minus 1 plus 1. So this implies 6 plus 1. So this implies 7. So in case of ternary tree, in case of ternary means this is the strict ternary tree. You can see over here, this is not a full ternary tree. This is the strict ternary tree. So in case of ternary tree, either it is a strict or the full. If the number of internal node is 3, then the number of leaf node will become 7. You can check it over here. 1, 2, 3, 4, 5, 6, 7. So this is the correct formula. This is the correct formula. So if you are able to understand these all formula, let's try to solve one of the numerical related with your GATE exam. So just see over here. So this is the question from the GATE 2007. This is the question from GATE 2007, 2 marks. Take your time and tell me the answer, all of you. Okay, let's see. What is given? A complete n-ary tree. Of course, if n is equal to 2 binary, n is equal to 3 ternary. So if it is an n-ary, okay, n-ary tree is a tree in which each node has n children or no children. So what does it mean? N children or no children, this is the nothing but a strict n-ary. Yes or no? Strict n-ary tree, because this is the definition of the strict n-ary tree. If n is equal to 2, it will become the strict binary tree. If n is equal to 3, it will become a strict ternary tree. Are you getting my point or not? So it is given as let I be the number of internal nodes and L be the number of leaf nodes in a complete n-ary tree. So if L is equal to 41 and I is equal to 10, what is the value of n? What is the n over here? N is the order of tree. Order means maximum number of children a tree will have. So just see over here, just apply the formula. In case of strict n-ary tree, n is equal to I into n minus 1 plus 1. So all the parameter is given. The value of L is given as 41 is equal to 10 n minus 1 plus 1. So just take the 1 on the left hand side. So it will become 10 into n minus 1 is equal to 40. This 0 will be deducted. Now the n will become 4 plus 1 is equal to. Got it. So the right answer of this question will become C. Again, let's see the question of GATE 1998. Okay, this is the one of the interesting problem you will have. So just try to solve this question. Okay, so what is the question is asking? Which of the following statements is false? You have to tell me the false answer. Okay, so a tree with the n nodes has n minus 1 edges. So of course you can see over here. You can see over here, this is a tree. This is the tree, and how many nodes are there? 1, 2, 3, 4, 5. So if the number of nodes are 5, then what are the total number of edges? You can see over here. This is the first edge, second edge, third edge, fourth edge. So the number of edges will definitely n minus 1 if it is a tree. What is the n over here? this is the 5 minus 1 is equal to 4. Got it? So saying a tree with the n nodes having n minus 1 edges, this is the true statement. This is the true statement, but you have to find out the false statement. So let's see the option B. A labeled rooted binary tree can be uniquely constructed given its post order and the pre-order traversal result. So my dear friend, this is the matter of traversing. This is the matter of traversing. Right now we don't know about this, so I'm not going to discuss the option B. Okay, but we will try to check all the options C and D. Okay, see over here. Again, a complete binary tree with n internal nodes has n plus 1 leaves. So still we don't know about this. We don't know about the definition of the complete binary tree. So again, we will look upon this statement later on. Okay, so just see over here. The maximum number of nodes in a binary tree of the height h is, you can answer this. See guys, see, if I am considering height is equal to 2, what kind of tree you can draw? This is the first tree that you can draw. This is the second tree that you can draw. This is the third tree you can draw. Yes or no? And this is the fourth tree you can. Okay. And this one is the fifth tree that you can. So all trees are with the height h is equal to 2. So in this case, there are 3 number of nodes, there are 4 number of nodes, there are 5 number of nodes, there are 6 number of nodes, there are 7 number of nodes. So of course, this is the maximum value. So when you will be able to achieve the maximum value, if it is a full binary tree, then you can achieve the maximum value. And in case of full binary tree with height h, what will be the total number of nodes? Already we have derived this formula. So this one will become the to the power h plus 1 minus 1. So this is the true statement. So we have identified this one is true and this one is true, but you need to answer the false statement. So we have to look upon the statement B and C. So later on we will see about this. Once we will cover up the complete binary tree and traversing technique, then we will come to this problem and again we will try to solve it. But till now we have removed the 50% difficulties. 50% जो भी डिफिकल्टीज आनी थी वो हमने हटा दिया है. अब मुझे सिलेक्शन 2 ऑप्शन में करना है, बी एंड सी. ठीक है ना? तो हमारा जो एक्यूरेसी लेवल होगा वो अब 2 ही ऑप्शंस पे होगा, तो वो हम लोग देखेंगे. नाउ लेट्स टॉक अबाउट ऑलरेडी वी हैव सीन द स्ट्रिक्ट एंड फुल बाइनरी ट्री. नाउ लेट्स टॉक अबाउट द कंप्लीट बाइनरी ट्री. थर्ड हमारा क्या था? कंप्लीट binary. So my dear friends, before talking about the complete binary tree, you have to understand the representation of binary tree in memory. Representation of binary tree in memory. See over here. Representation of binary tree in मेमोरी. देखिए 2 तरीके से मेमोरी में किसी भी बाइनरी ट्री को रिप्रेजेंट करते हैं, है ना? सबसे पहला है लिंक लिस्ट, दूसरा है एरे रिप्रेजेंटेशन. एरे first one is the linked list representation and the second one is the array representation. Let's try to understand what I am trying to say. Suppose I am creating a binary tree. This one is 50, this one is 70, I'm talking about only binary tree, not a complete binary tree or not a binary search tree, AVL tree. Are you getting my point or not? This one is 40 and this one is 30. This one is 20. This one is 60. Okay. So how to represent this tree with the help of linked list? See over here. See, since this one is the root node, so what we will do, we are creating a node. What is the data over here? This one is 50. And what is the address of this node? This one is 200. Of course, this is the doubly linked list because there are two pointer address. Okay. So this is the left child of this, means we are keeping this at the address 100, we are keeping this at the address 200, we are keeping this at the address 300, so on. So at the 200 address, which one is the next node? So the next node will become the 70, and again we are assuming this is at the address 400, this one is 500, and this one is 600. So of course, on the left hand child, on the left child of this, it will be a 400. So of course, this will be connected with, and here it is a 40. Since there is no right child, it will become null. So again, this one is 300. Means this is connected to, what is the data? This is the, this one is 500, this one is 600. And every node having their address. Okay, we will mention it later on. This one is 20, this one is, now let's see, since this node do not have any right child, so it will contain the, okay, so this will contain the null. I'm just indicating the null by cross. Okay, this is at the address 100, this is at the address 200, this is at the address 300, this is at the address 400, this is at the address 500, this one is at the address 600. So this is simply a linked list representation. Of course, there will be a root node. There will be a root node containing the address of the root. This one is connected to this. So this is the root variable which will contain the address of the root node, means starting, so that you can start the traversing. Okay. So similarly, what is the array representation? My dear friends, this is the index 0, 1, 2, 3. If there is a right child, then it will be at the index 4, 5, and this one is 6. So once you will represent this tree with the help of array, what will happen? Just see over here. 1, 2, 3, 4, 5, 6. This is the index 0, 1, 2, 3, 4, 5, 6. So what is the element at the 0 index? This is the 50. At the 1 index, 70. At the 2 index, this one is 40. At the 3 index, this one is 30. At the 4 index, there is no element. So this is the blank. And at the 5 index, this is the 20. At the 6 index, this is the 60. So since every node can have a maximum 2 child, so in this index, there is no children. In this index, there is no children, and that's why we are keeping this place as a empty. We are keeping this place as a, and by the array representation, we basically represent the complete binary tree. We represent the complete binary, and from here the definition of the complete binary tree was given. From here the definition of the complete binary tree was given. Now let's try to analyze the definition of the complete binary. Okay, see over here. See, complete binary. Okay. So in case of complete binary tree, means if you will represent any tree, any binary tree with the help of array, and if there is no gap between the elements, then it will be known as complete binary tree. Otherwise, आप किसी भी बाइनरी ट्री को जब एरे से रिप्रेजेंट करोगे और उस एरे में अगर कोई गैप क्रिएट नहीं हो रहा है, तो इट विल बी कॉल्ड अ कंप्लीट बाइनरी ट्री. गॉट इट? सो when we represent, just giving you a formal definition, represent a binary tree with array, then it is called complete binary tree. I'm just representing CBT as a CBT. C means complete, B means binary, T means tree. Then we called it as a complete binary tree if there is no gap between elements. Just giving you an example. See over here. This one is the first. This one is the second. This one is the third. This one is the, just see over here. So this element will be definitely at the index 0, 1, 2, 3, 4, and this is at the index 5, and this one at the index 6. Again, this one at the index 0, 1, 2. Of course ये elements नहीं है, लेकिन इसके अपने तो index होंगे ना, 3, 4, 5 and 6. This is again at the index 0, 1, 2, 3, 4, 5. Okay. और ये अगर होता तो इसका 6 होता. Similarly 0, 1, 2, 3, 4, 5, 6, अगर यहाँ पर भी इसका होता तो ये 7 होता. ठीक है ना. चलिए, मैंने क्या बोला है कि if there is no gap between the elements, then it is called a complete binary tree. So just see over here, whenever you will represent this tree with the help of array 1, 2, 3, 4, 5, 6, so this position will be filled. This is the index 0, 1, 2, 3, 4, 5, 6. This position will be filled, again filled. This one is gap, again filled. So this one is the gap. So if there is a gap, then it is not a complete binary tree. Are you getting my point or not? Similarly, in this situation, what will happen? 1, 2, 3, 4, 5, 6. Again, this is the index 0, 1, 2, 3, 4, 5, 6. Filled, gap, again filled. So there is a gap. So if there is a gap, then it is not a complete binary tree. Similarly, look upon this. So 1, 2, 3, 4, 5, 6. This is the index 0, 1, 2, 3, 4, 5, 6. So again filled, again filled. So is there any gap? No. So it will become a complete binary. Got it. Similarly, this one is also become a complete binary. Clear everyone? So this is the basic definition of the complete binary tree. So I have a two different question. देखिए, ये जो ट्री है, इस ट्री को अगर आप गौर से देखो, ये कंप्लीट भी है और फुल भी है. ठीक है ना? Now let's analyze the things. If you will look upon this particular tree, the first thing that came in our mind is this is the full binary tree. Full binary. So if it is a full, then it will be a strict, and if it is a full, definitely it will be a, okay, means what you can say, every full binary tree will be a strict as well as complete. Okay, this is the first point. Now the second point is, जो हम लोगों ने फॉर्मूला लिखा था, क्या ये फॉर्मूला कंप्लीट बाइनरी ट्री के केस में वैलिड है या नहीं है? वेदर L is equal to I into n minus 1 plus 1 is valid for complete बाइनरी ट्री. बहुत ही सिंपल सा एक्सप्लेनेशन है. देखिए हम लोग एक बाइनरी ट्री कंसीडर कर रहे हैं. ऑफ कोर्स किसी भी बाइनरी ट्री में n का वैल्यू 2 होगा, मींस L इक्वल टू क्या होगा, I प्लस 1. मींस लीफ नोड का जो काउंटिंग है वो इंटरनल नोड से एक ज्यादा होना चाहिए. जस्ट सी द एग्जांपल. सो दिस ट्री is a complete binary tree, yes or no? और इस complete binary tree में internal node कितने हैं? 3 है. I भी 3 है और leaf node भी कितने हैं? 3 है. Which is basically indicating, means this particular formula is not valid for the complete binary. This particular formula is not valid for the complete binary tree. Got it, everyone? So in this way, looking upon the real visualization, you can easily answer any kind of question. Got it? So this is all about the complete binary tree. Now let's try to analyze something about the complete binary tree. क्योंकि अल्टीमेटली हम लोग कंप्लीट बाइनरी ट्री को आगे मैक्स एंड मिनिम में यूटिलाइज करेंगे. देखिए, प्लीज नोट इट डाउन. वी यूज concept of complete binary tree to build heap tree. Later on I will tell you how to implement the concept of the complete binary tree to build the heap tree. Now there are something interesting to know about the complete binary tree. See over here, I am just creating a complete binary tree. देखिए, अब ये जो बाइनरी ट्री है ये कंप्लीट भी है और फुल भी है, और इस बाइनरी ट्री में इसका इंडेक्स क्या है, 0 है, बिकॉज हम लोग इसको एरे से रिप्रेजेंट कर रहे हैं. देखिए, बाकी जितने भी बाइनरी ट्री हैं उन सभी को लिंक लिस्ट से रिप्रेजेंट किया जाता है. बस एक कंप्लीट बाइनरी ट्री एक ऐसा ट्री है जिसको हम लोग एरे से रिप्रेजेंट करते हैं. बट वंस यू आर रिप्रेजेंटिंग इट बाय द एरे, देयर विल बी अ इंडेक्स ऑफ ईच एंड एवरी नोड. यहाँ पर एड्रेस नहीं होगा, यहाँ पर क्या होगा, इंडेक्स होगा. So this is at the index 0, this is at the index 1, this is at the index 2, this is at the index 3, this is at the index 4, 5 and 6. Now I have a two different question. मेरे पास दो अलग अलग क्वेश्चन है कि अगर किसी भी कंप्लीट बाइनरी ट्री में, here I am talking about the complete binary, please remember I'm talking about the complete binary tree. So किसी भी complete binary tree में किसी भी parent का अगर index, suppose I am considering this is the parent, this is the parent node. तो किसी भी parent node का index अगर I है तो इस parent का 2 children possible है. भाई ये वाला चिल्ड्रन हो भी सकता है, नहीं भी हो सकता है. इफ इट इज अ कंप्लीट बाइनरी ट्री, then it may be possible or it may not be possible, but I am considering all the possibility. तो अगर पेरेंट का इंडेक्स आई है तो इसके चिल्ड्रन का इंडेक्स क्या होगा? चलिए, तो डेफिनेटली इसके चिल्ड्रन, इस वाले चिल्ड्रन का इंडेक्स क्या होगा? 2i+1, और राइट चिल्ड्रन का इंडेक्स क्या होगा? 2i+, so this is the index of left child and this is the index of right child. Yes or no? 2i+1 means 5 and 2i+2 means 6. This is always valid. This is always valid in complete. So this is the first concept. This is the concept number A. Now let's try to analyze the concept number B. अब रिवर्स ऑर्डर पे सोचो कि अगर किसी भी चाइल्ड का इंडेक्स आई है तो उसके पेरेंट का इंडेक्स क्या होगा? ठीक है ना? आई एम जस्ट डूइंग द सेम थिंग इन अ रिवर्स ऑर्डर. 0 1 2 3 4 5 6. Suppose I am assuming this is the children. Okay, this is the children. Child having index I, having index I. Find index of parent. Find index of, ओके, तो पेरेंट का इंडेक्स क्या होगा? चलिए, आपके दिमाग में जो भी आ रहा है आप इसको यहां पर सोच सकते हो, आप मुझे आंसर बता सकते हो. देन वी विल ट्राई टू फाइंड इट आउट. सी ओवर हियर, अगर इसका इंडेक्स 5 है तो माइट बी यू आर थिंकिंग सर द इंडेक्स ऑफ द पेरेंट विल बिकम 5-1 divided by 5-1 divided by 2. तो ये कितना आ जाएगा? वो आ जाएगा. ऑफ कोर्स ये भी तो चिल्ड्रन है, तो इस चिल्ड्रन का इंडेक्स कितना है? 6 है, और ये दोनों चिल्ड्रन का सेम पेरेंट है. तो इस चिल्ड्रन के केस में भी आपको फॉर्मूला अप्लाई करना पड़ेगा. तो 6-1 डिवाइडेड बाई 2, ये कितना आ जाएगा? दिस विल कम आउट टू बी 2.5. So definitely you have to consider the selling value. You have to consider the selling value. It will become. So finally यहां पर अब 2 का आप सेलिंग लो या फ्लोर लो कोई फर्क नहीं पड़ता है. सेलिंग लो या नहीं लो उससे भी कोई फर्क नहीं पड़ता है. तो फाइनली what we can write looking upon these things, what we can write, the index of parent index will become I-1 divided by 2 floor value. Got it? Floor value. Is that clear to all of you? बात समझ में आ रहा है? It is very much clear with the diagram. Now the question is, why we are trying to find out the index of child if you know the index of parent, and if you know the index of child, then how to find out the index of parent? Why these things is needed? तो ये बातें आपको तब समझ में आएगी जब हम लोग डील करेंगे हिप ट्री को. So the application of this concept will be used in हिप ट्री. जब हम लोग मैक्स हीप मिन हीप को बिल्ड करेंगे ना और इसके प्रोग्रामिंग स्ट्रक्चर को देखेंगे, then you will be able to realize there is a huge application of these two different concept. जब हिपिफाई प्रोसेस होता है तो यहाँ पर यही कॉन्सेप्ट यूज होते हैं. ये सारे इंडेक्स आपको पहले से पता होना चाहिए. Got it? So we will look upon over. Now let's come to the binary search tree. Let's come to the binary search. So my dear friends, what is the meaning of binary search tree? देखिए बाइनरी ट्री तो है ही है, लेकिन यहां पर एक टर्म्स यूज हो रहा है सर्च, मीन्स अ ट्री विच इज यूज फॉर सर्चिंग अ एलिमेंट. बाइनरी ट्री used to search a key. सो अगर एक ऐसा बाइनरी ट्री जो किसी की को सर्च करने के लिए यूज हो रहा है, द स्ट्रक्चर ऑफ द ट्री विल हैव सम रिस्ट्रिक्शंस. ट्री का जो भी स्ट्रक्चर डेवलप होगा वो एक पर्टिकुलर प्रोटोकॉल्स या रूल्स के अकॉर्डिंगली होगा. यस और नो? कि रैंडमली आप कोई भी ट्री का स्ट्रक्चर नहीं बना सकते हो. अगर आप बनाते हो तो क्या होगा दोस्तों, वहां पर टाइम कॉम्प्लेक्सिटी एक फैक्टर अराइज हो जाएंगे. बट इफ यू आर फॉलोइंग अ पर्टिकुलर रूल्स टू डेवलप अ ट्री, then it will directly affect the time complexity. See, अगर हम लोग किसी भी एरे में किसी एलिमेंट को सर्च करते हैं तो किस पोजीशन में एलिमेंट है वी एग्जैक्टली डोंट नो. सो वी नीड टू लुक अपॉन ईच एंड एवरी लोकेशन. So if the size of the array is n, then we basically say the time complexity to search a particular key will be order of n, because you have to traverse to the entire array. क्योंकि यहां पर कुछ फिक्स नहीं था. सिमिलरली अगर ट्री का कोई पर्टिकुलर स्ट्रक्चर नहीं है, अगर ये सिंपल बाइनरी ट्री है, तो आपको क्या करना पड़ेगा, आपको ट्री के हर एक नोड को ट्रैवर्स करना पड़ेगा. सो ईदर इट इज अ पोस्ट ऑर्डर ट्रैवर्सल, और इट इज अ प्री ऑर्डर ट्रैवर्सल, और इट इज अ इन ऑर्डर ट्रैवर्सल. इट विल टेक अ ऑर्डर ऑफ n टाइम, एंड आई विल टेल यू व्हाई इट इज टेकिंग द ऑर्डर ऑफ n टाइम. क्योंकि ट्रैवर्सिंग का मतलब क्या होता है, ग्राफ के हर एक नोड को ट्रैवर्स करना. By the traversing each and every node, you are trying to check whether the search key is equivalent to the key of the node or not. तो अगर वहां पर किसी भी बाइनरी ट्री में n नंबर ऑफ नोड है और हर एक नोड पे आप विजिट कर रहे हो, टाइम कॉम्प्लेक्सिटी विल बी द ऑर्डर ऑफ n. But in the entire computer science, our major target is to reduce the time complexity. If you want to reduce the time complexity, then you have to change your logic. अब आपको क्या करना है, आपको अपने लॉजिक को चेंज करना है अगर आपको टाइम कॉम्प्लेक्सिटी रिड्यूस करना है. एंड दैट लॉजिक विल पुट सम रेस्ट्रिक्शंस इनसाइड द बाइनरी ट्री, एंड इट विल क्रिएट अ बाइनरी सर्च ट्री. सो व्हाट इज द बेसिक, मुझे पता है आपको बाइनरी सर्च ट्री का बेसिक डेफिनेशन पता है, लेकिन लेट मी टेल यू वंस अगेन. ओके, बाइनरी सर्च ट्री का बेसिकली डेफिनेशन क्या है कि ये अगर रूट नोड है तो हर एक नोड का मैक्सिमम 2 चिल्ड्रन हो सकता है. तो लेफ्ट चाइल्ड जो है ये इससे छोटा होना चाहिए और राइट चाइल्ड ये इससे बड़ा होना चाहिए. एंड दिस कंडीशन शुड बी वैलिड फॉर ईच एंड एवरी नोड. फॉर ईच एंड एवरी नोड. ऐसा नहीं है कि कुछ नोड पे ये कंडीशन वैलिड है कुछ पे नहीं है, तो ये बाइनरी सर्च ट्री नहीं होगा मेरे दोस्तों. ठीक है ना? सो every, I'm using the term every root node will have left child lesser than it, and right child greater than if left and right child exist. Right child exist. घड़ी में पॉइंट और भाई लेफ्ट राइट चाइल्ड हो भी सकता है नहीं भी हो सकता है. ठीक है ना, किसी किसी नोड के. चलिए देखते हैं. सपोज आई एम टेकिंग सम एग्जांपल. जस्ट टेक अ एग्जांपल. सपोज दिस इज द 50. सो इसके लेफ्ट चाइल्ड इससे स्मॉलर होना चाहिए 40, और ये इससे ग्रेटर होना चाहिए 60. अगेन इफ दिस इज द रूट नोड, इसका लेफ्ट चाइल्ड इससे लेसर होना चाहिए. सपोज दिस इज द 30 और राइट चाइल्ड इससे ग्रेटर होना चाहिए. दिस इज द 40. Again, if this is the root node, the left child should be lesser than this. Suppose this is the 55, the right child is 70. So of course this is the binary search tree. Okay, take the next example. 50, 40. Left child should be less than it, and right child can exist or cannot exist. ये हो भी सकता है, नहीं भी हो सकता है, लेकिन अगर होगा तो इससे हमेशा ग्रेटर होना चाहिए, 40 से ग्रेटर होना चाहिए. Similarly, this is the 60, this is the 55, and this is the 70. Again, this one is binary search tree. Take the next example. 50, 40, 60, 40, 45, and this one is 20 and 70. So just see over here. देखिए जो कंडीशन है वो इस नोड पे वैलिड है. ये अगर रूट है तो इसका लेफ्ट और राइट चाइल्ड लेस है एंड ग्रेटर है. ये अगर रूट है, इसका लेफ्ट चाइल्ड लेसर है, इसके राइट चाइल्ड ग्रेटर है. ये अगर रूट है तो ये वाला नोड उस कंडीशन को फॉलो नहीं करता है. मीन्स इफ एनी वन ऑफ द रूट नोड इज वायलेटिंग द कंडीशन, देन इट विल नेवर बी अ binary search tree. It will never be a binary search tree. Got it, everyone? So this is the basic definition of the binary search tree, which is basically used to search a particular key in a tree. So let's see one more example. See over here, 50, then 60, then 70, then 80. So of course this is the binary search tree, क्योंकि ये अगर रूट है तो इसके लेफ्ट चाइल्ड अगर एग्जिस्ट ही नहीं कर रहा है तो कोई फर्क नहीं पड़ता. राइट ग्रेटर है, ग्रेटर है, ग्रेटर है. So of course this is the binary search tree. Okay, now let's solve this particular example. ये एग्जाम्पल में हम लोगों ने देख लिया था कि ये स्टेटमेंट फॉल्स है और ये भी ट्रू है, ये भी स्टेटमेंट ट्रू है. Now let's talk about the statement means option C. ऑप्शन सी में क्या गिवन है? अ कंप्लीट बाइनरी ट्री विथ n इंटरनल नोड्स हैज n plus 1 लीव्स. जस्ट ट्राई टू चेक इट ओवर हियर. एक हम लोग कंप्लीट बाइनरी ट्री लेते हैं, ठीक है. इस कंप्लीट बाइनरी ट्री में ये सभी इंटरनल नोड्स हैं. तो नंबर ऑफ इंटरनल नोड को यहां क्या बोला गया है? n इंटरनल नोड. सो हियर the value of n is 3 and these are the leaf node. So the number of leaf node is equal to also 3. लेकिन ये बोल रहा है कि number of leaf node should be n plus 1. This is not necessary in case of complete binary tree. What I have told you, see this particular formula, n is equal to I plus 1. This is only valid for two different kind of tree. One is the strict, second one is the full binary tree. But if it is the complete, this may be valid or this may not be valid. Because if you are considering this tree, of course this is the complete as well as strict. This is the complete as well as strict. So somehow the properties of the strict binary tree is coming over here. Got it? But for every complete binary tree, this particular formula is not valid. So my dear friends, this particular statement is false. Got it? So एक बात तो समझ में आ गया कि ये हमारा आंसर होगा. But still this is the suspense. This is the suspense कि ऑप्शन बी होगा या नहीं होगा. देखिए 98 में इस तरह के क्वेश्चंस आते थे, लाइक एमएसक्यू टाइप क्वेश्चन. एक से ज्यादा ऑप्शन ट्रू भी हो सकता है. इस तरह के क्वेश्चंस पहले आया करते थे. तो हो सकता है कि ऑप्शन बी भी फॉल्स हो और यहां पर दो अलग अलग ऑप्शन ट्रू हो जाए. Got it? So these are the question from the 1998 and the same pattern has been implemented from the GATE 2021. So my dear friend, just be with me. I will continue this session on tomorrow. जैसा कि मैंने आज आपको बेसिक कॉन्सेप्ट जितने भी ट्री है उसके बता दिए. कल हम लोग देखेंगे बाइनरी सर्च ट्री का एक्सट्रीम लेवल, ठीक है ना. और उसके बाद हम लोग देखेंगे AVL ट्री. We will try to find out the drawback of the binary search tree and then we will move to the AVL tree with respect to the time complexity. So that's all for today. So dear students, if you are liking this video, then don't forget to use the code IFA and put your valuable comments. देखिए अगर आप लाइक करते हो तो चैनल को जरूर सब्सक्राइब करिए. ये आपका कोड है जो आप फ्री स्पेशल क्लासेस में भी यूज कर सकते हैं, प्लस सब्सक्रिप्शन के लिए भी यूज कर सकते हैं, और आपको मिनिमम 10% का डिस्काउंट मिलने वाला है। ओके, प्रेस द बेल आइकन बटन टू गेट द नोटिफिकेशन एंड पुट योर वैल्यूएबल कमेंट्स, बिकॉज योर वन वैल्यूएबल कमेंट विल इंस्पायर द मेनी स्टूडेंट्स हु आर प्रिपेयरिंग फॉर द गेट। गुड नाइट, टेक केयर, रब्बा खैर, मस्त रहिए, मेहनत करिए, आगे बढ़िए। लाइफ में कुछ अच्छा आपके लिए जरूर वेट कर रहा होता है, बस जरूरत है तो मेहनत करिए। बाय, टेक केयर।